Okay, a lot of this is going to be review here, but let's start talking about polynomials and polynomial functions. Okay, my first definition here is going to be a monomial. A monomial is just a constant multiple of power function. Okay, so some examples would be like this: 7x squared, that would be a monomial. Negative 13x cubed, that would be a monomial in x. Okay, 5y to the 8th, that would be a monomial in y. Okay, even something like this, say 18, even that is going to be a monomial term, because we could think of that as what, 18 times x to the 0 power. Okay, so a monomial, just think of it as what, a constant multiple of a power function. Okay, in a single variable here, let's maybe throw in one more, x to the 5th all by itself. That would be an example of a monomial. That's really 1x to the 5th, isn't it? Okay, usually we suppress that factor of 1 out front, but we could include it if we want. Okay, what's a polynomial? A polynomial is just a sum or difference of monomials. So take some examples here. I could have 7x squared minus 5x plus 3. That would be an example of a polynomial. Now, I might give that a name like p of x, p for polynomial, or I might call it f of x or something. Okay, do you see there's what? 3 monomials here: 7x squared, negative 5x, and 3, which I've added together. Or if you want to consider that subtracting 5x, that's fine too. Clearly, this thing is going to be a function here. Okay, we've talked about functions before. For any value of x, I can plug in here, right? I'll get a single value coming out. Polynomial functions, I might mention, always have a domain which is all real numbers. Okay, we've mentioned that before also. The term poly is Greek for many. Mono is Greek for one. For example, monocle or monocycle, that just means one, right? Poly means many. Here's some other things. What does binomial? What is binomial? What does bi mean? Okay, that means two, right? So this would be an example of a binomial. 6x plus 11, that would be a binomial, okay? Because how many terms does it have? It has 2 monomial terms, right? What's a trinomial? Well, tri means 3, right? So this would be what? For example, 7x squared minus 5x plus 3. Okay? So our p of x above, that's a trinomial. There are indeed 3 monomial terms, or we just say 3 terms. Okay? Alrighty. So polynomial in general just refers to what? Monomial, binomial, trinomial, or polynomials with so many terms we don't know, have any special name for them. Alrighty, let's talk about the degree of a monomial term. Okay, so let's say I have a monomial term like this or this or this. Okay, what's the degree? Let's take an example. The degree of, say, 7x squared is 2. Okay, it's the power on x that you're dealing with. Okay, so this is of degree 2. Okay, what's the degree of this? Is what? Degree 3, right? Because that's a power in x here. How about the degree of this? 4x is 1, right? The power on there is implicit, but if we wanted to include it, it would be 1. That's degree 1. And then how about the degree of a constant? Degree of, let's say, 13 is 0. Okay? By the way, I'm not going to go into it. Some people would make an exception here for a constant term. The degree of 0 is sometimes referred to minus infinity, believe it or not, for certain various and sundry reasons that we might discuss later. But anyways, I hope you understand this, that this is actually of degree 0, because I can think of what? 13 being 13x to the 0 power, right? Okay. Alrighty, so there's degree of the individual monomial terms. Let's talk about the degree of a polynomial. Now, a polynomial is made up of many terms, okay? So, for example, how do I define the degree of a polynomial like this? Minus 7x plus 5x squared plus 8, okay? Well, this is how the degree of a polynomial is defined. You go through it term by term and find the degree of each term. What's the degree of that term? That's degree 1. This is degree 2. This is degree 0, right? Now you look among those numbers and you find the largest of them. The largest of these three numbers is 2. So this has degree 2. Degree of this is, therefore, 2. Okay? So that's how we define the degree of a polynomial. Okay? Degree of, 4x to the 4th minus 5x to the 7th plus 8x plus 13. You can just read it right off. It would be, looking through these, the degree is 4, 7, 1, 0. The largest is 7. So this is a degree 7 polynomial, we would say. Okay, so that's the degree of a polynomial. All right. Let's talk about convention we often use when writing our polynomials or polynomial functions. Okay, suppose I have a polynomial function like this. I'll call it f of x here, though I don't really need to name it. I got negative 7x squared plus 4x cubed minus 5 plus 13x. Okay, now if you actually read the degree of each term that makes up this polynomial, this would be what? Degree 2, degree 3, degree 0, degree 1. Okay, so 2, 3, 0, 1, these numbers are not in order. Okay, these numbers are not in order. Certainly in the sense of they're not descending order. What is descending? This means decreasing order would be another way to say it, decreasing order. And I would actually argue that a better term we ought to use is descending degree. Okay, so let me show you how we rewrite this. What you do is when you're reading the terms of the polynomial from left to right, like reading a book, the degrees should be dropping. Okay, so now I'm going to reorder my terms here. Let's see, the highest degree term was what? The third degree term here. This was 4x cubed. The next highest one was the second degree term. That was minus 7x squared. The next highest one was the first degree term. That was our 13x. And then we've got minus 5 at the end. So we've got degree 3, 2, 1, 0. Okay? So there we've rewritten that polynomial so it's now in descending order. We're going to find descending order a very convenient way of writing our polynomials. By the way, in the future, and if you go on to calculus and stuff, you'll also find out ascending order. So writing it in the opposite way, ascending order, is something that can also be very useful. What's not useful is having a jumbled up order like this, typically. Okay, a jumbled up order like that. Okay, so be able to write polynomial functions in descending order. Okay, that's what we'll be using in this class. Missing terms. Let's go ahead and talk about what missing terms are here. This polynomial is actually in descending order. It has what? 7x cubed, so that's third degree. 4x, that's first degree. And then what? Degree 0, because that's a constant term, right? Okay, you guys notice that something's missing in that series of numbers? 3, 1, 0. Now, naturally, when you're counting down from 3 to 0, you would have what here? 2, right? 3, 2, 1, 0. The second degree term is actually missing from this polynomial. That's okay. There's nothing necessarily wrong with that. But we might like to include it, and we will in certain situations here, that we'll see, for example, when we're dividing polynomials using long division, we will want to sometimes include missing terms here. Now, if I include the missing term there, remember, I can't really change the value of the polynomial function here. So what we imagine is including that x squared term, but its coefficient, right? The number in front of the term is 0. Yes. Oh, I probably didn't even say that, though. You're familiar with it, no doubt. The number that I'm, like when I'm talking about constant multiples of power functions, the multiple in the front is sometimes called the coefficient. Okay? The coefficient. So there, anyways, I've rewritten that polynomial in descending order. Okay, now let's go on and let's talk about adding and subtracting polynomials. Again, this stuff is no doubt a review for you. All right. Let's go ahead. Let's add these two polynomials. What we're simply going to be doing is combining like terms in essence, and we're adding and subtracting here. Now let me show you a convenient way of actually computing the sum or difference of polynomials. Write them in descending order, and sometimes if you want to include missing terms, that would be pretty nice here. I don't think I actually have to do that in this particular example. Okay, I'm going to just put this out here. Reminds myself I'm adding these two. But I've got what? The nice thing I want to do here is have like terms underneath each other. You remember that from your earlier algebra classes? Like terms have what? The same variables appearing to the same powers. Okay, there's only going to be we're only dealing with polynomials in a single variable for now, so there should be no ambiguity as far as which variable you're talking about. Here I'm dealing with x here. So I'm saying they're like terms if they occur to the same power. In other words, if they have the same degree, the terms. Okay, so these are like terms, and then we just add them. Now using the distributive property, because these have what? A common factor of x cubed, I can simply add the coefficients. 17 and 6 is 23, so I get 23x cubed. Notice that I actually have a missing term here. I could have included it as I stated there. It's really not going to do me any good here. Adding 0x squared to 5x squared, I still get the 5x squared. And now let's add these two. What do we get? Negative 11 plus 8 is negative 3, so I get negative 3x. 13 and 1 is 14, so here is my final answer. Okay, I often like to do this rather than writing a long, big long string of terms and stuff here. We'll see this in particular when we're talking about multiplying polynomials. Okay, anyway, let's go ahead and do one subtraction problem. We will get more practice in both of these when we're multiplying and dividing polynomials. So I'm not going to spend too much time on this right now, besides the fact that you've no doubt seen it before. Now I'm putting this here in parentheses. This is not attached to any particular term. I'm just reminding myself that I'm subtracting. Okay, again, like terms. 17x cubed minus 6, that would be what? 11x cubed. 5x squared minus 0x squared, essentially. Okay, negative 11 minus 8 is negative 19. X 13 minus 1 is 12. And so here is the difference of our two polynomials. Okay, so adding and subtracting polynomials is pretty easy. And like I said, we're going to get a lot more practice in that when we're multiplying and dividing polynomials coming up. Okay, let's talk now about multiplying polynomials. Okay, here I'm going to multiply these two polynomials together. Multiplying polynomials simply amounts to the use of the distributive property together with our exponential notation. Okay, there's the associative property also used in there and some commutative property, but it's going to be pretty basic stuff here. Again, you've probably seen this already here. So-called FOIL, here I have two binomials. I'm multiplying them together. The key is to take every term on this polynomial and multiply it on every term on this polynomial and then combine like terms. That's about it. Okay, so I'm going to go 2x times 4x. That's going to go the 2 times the 4 using the associative and commutative property. That gives me the 8, and then the x times the x is really x squared. Then I'm going to go the 2x times the negative 5. That's negative 10x. Okay, so I've multiplied this guy on both of these. Okay, now I'm going to multiply this guy on both of these, and I would get what? 3 times 4 is 12x. Now I left that there for students. I've often seen this where what? They're not connecting their terms with everything. What should be the operation between these? It should be a plus sign, right? Don't just have terms floating next to each other. What's 3 times negative 5? Negative 15. Okay, operations between all the monomial terms. And now you guys notice that these two middle terms are actually like terms. Negative 10x plus 12 gives you what? 2x. Okay. And this is going to be our final answer that we're going to box in. Okay, now when I multiplied these two binomial terms, I got what? 1, 2, 3, 4 raw terms. I say raw terms, those are terms that resulted just from multiplying the various monomial terms together. Okay, some of them are like terms, right? So in the end, we actually only had what? 3 terms in our answer. This is a trinomial, right? Of degree 2. Okay, remember all our terminology here. Now, come back here. Why did we have 4 terms? We had 4 terms because I have 2 terms here, multiplying on each of these 2 terms here, and 2 times 2 is 4. Okay? Now, if I look here, when I'm multiplying these 2 trinomials here, I have 3 terms here, and I have 3 terms here. How many raw terms am I going to end up getting when I multiply these 2 together? 3 times 3 is 9. I'm going to have 9 raw terms. Now, what I like to do, and I'd like to have my students do, is not write all 9 of those raw terms in a big long line. What I would like students to do is write like terms stacked on top of each other or beneath each other. Okay? All ready? Watch. Here's what I'm going to do here. Now I'm going to start out multiplying from left to right like usual. I'm going to go 3x squared times the 4x squared yields 12x to the what? 2 plus 2 fourth power, right? There's actually 4 x's being multiplied together. xx times xxx, times xx is x to the 4th. I don't want to say that again. Okay, 3x squared times the 5, that gives us what? Plus 15x cubed, and then what? Plus 3x squared when it multiplies on the 1. And now some people, now you'd start multiplying with the negative 2, right? And multiply it on there, and you would get what? Now hold your horses. You would get negative 8x cubed. I'm not going to write it right next to that there. I'm going to write it underneath the cube here. So I get just negative 8x cubed. Oh, that's going to make it really easy to combine like terms in the end, you see. Okay, and then keep going. The negative 2x times the 5x gives negative 10x squared, and the negative 2x times the 1 give negative 2x. Okay, not done yet. I've got to multiply with the 7. The 7 times the 4x squared yields, I'm not going to write it here, I'm going to write it under here. That gives what? 4 times 7 is 28x squared. Okay, notice how I'm lining these up. 7 times 5 is 35, so I get 35x plus the 7 times 1 is 7. Okay, now I'm just going to combine these. They're all stacked up nicely, so I'll just do them in columns. 12x to the 4th. Now I've got 15 minus 8. That's what? Positive 7x cubed. Okay, I've got what? 3 and 28 gives me 31. Minus 10 gives me 21. So I've got plus 21x squared. 35 minus 2 is 33. So I've got 33x. And then I've got the 7 left there. And there is my answer. Okay? Okay? My answer ends up being what? A 4th degree polynomial. I multiplied 2 second degree or quadratic polynomials, right? We've used that term before. I end up with a 4th degree polynomial. 1, 2, 3, 4, 5 terms in the end, even though originally I had 3 times 3, 9 raw terms, some like terms combined to write this in the simplified form. Okay, so when you're multiplying a couple little polynomials together, like this, a couple binomials, there's really no advantage in using the stacking method to multiply them. But if you've got a lot of terms, I would like you to go ahead and write your product this way. Okay, stack those so you don't have to go down the line and scratch things out. When I've seen this where students, they use this and this term so that they knock them out. All right, I got all the 3rd degree terms. I got all the 2nd degree terms in a big long line. don't do that. It's really hard for your teacher to grade your work that way as well. Okay? Alrighty, so that'll be enough on multiplying polynomials. We'll see more of this junk as we go along. Okay? All right.